Welcome back to my YouTube channel, in which I have created the playlist of data science covering the basic and advanced concepts. So, my next topic is regression modeling. Now, let's discuss what is regression modeling. Regression modeling in data science refers to a type of statistical technique which is used to predict or estimate the relationship between dependent variable and one or more independent variables. It is a core concept in supervised learning where the goal is to make predictions based on historical data. Now, what are the key concepts involved in regression modeling? First, dependent variable. This is a variable you are trying to predict or explain. It is also known as target variable. Second is independent variable. These are the variables that influence or explain changes in dependent variable. It is also known as predictors and features. Third is model. The regression model is built using historical data. Fourth is assumption. Linear regression assumes a linear relation between dependent and independent variable, while other type of regression may capture non-linear relationships. Now let's discuss how to use regression modeling. First, prediction. Predict future values of dependent variable based on known values of independent variable. Second, trend analysis. Identify trends or patterns in data to make informed decisions. Third is insight generation. Understand relationship between variables. Example, how changes an independent variable affect the dependent variable. Fourth is optimization. Use regression models to optimize decisions in fields like finance, healthcare, and marketing. Then let's discuss for the types of regression models. First, linear regression. It is further of two types: simple linear regression, multiple linear regression. Simple linear regression, a straight line relationship between one independent variable and the dependent variable. Multiple linear regression involves more than one independent variable with linear relationship between the variables. Second is polynomial regression. Extends linear regression to model relationships that are non-linear by introducing polynomial terms or predictors. Third is random forest regression, an ensemble method that builds multiple decision trees and combines their outputs for more accurate predictions. Next is support vector regression. Uses support vector machines to predict continuous values, offering flexibility for non-linear regression problems. Next is decision tree regression. Uses decision tree algorithms to model complex relationships by partitioning the data into segments based on future values. Next is logistic regression. Although it's used for classification, but it's still referred to as regression because it predicts the probability of an event occurring. Now let's discuss what are the steps involved in regression modeling. First, data collection. Gather data that includes both dependent variable and independent variable. Next is data preprocessing. Handle missing values, outliers, and transform categorical variables if necessary. Third is model selection. Choose the appropriate regression model based on the nature of the data. Fourth is model training. Split the data into training and testing sets. Fifth is model evaluation. Evaluate the model using matrices like mean squared error, mean absolute error, root mean squared error, R square, etc. Prediction. Use a trained model to make predictions on new or unseen data. Now let's discuss what is stepwise regression and what are the three common approaches. Stepwise regression is a technique used for model selection in statistical modeling. It automatically selects significant variables by adding or removing predictors based on certain criteria, usually AIC or BIC. Now next is the three common approaches. First is forward selection. Start with new predictors and add predictors one by one based on statistical significance. Second is backward elimination. Start with all predictors and remove the least significant step one at each step. Third is bidirectional. Combines both forward selection and backward elimination, adding or removing predictors at each steps. Now let's move to the coding part. Here I have provided the code to demonstrate estimation model evaluation using Python. First, import required necessary libraries. Import NumPy with the alias name NP, pandas with alias name PD. Then import libraries such as load Boston to read data, train test split to perform splitting, linear regression to perform regression task, mean squared error, R2 score, meth. In order to read data, I have used load Boston and store data in Boston variable. Then I have to, in order to convert data to pandas data frame, I have used the format pt.dataframe and store the result in data variable. Then in order to read the target variable price, I have used the format data price boston.target. Then in order to display the first few rows of the dataset, I have used head function displaying the message first few rows of the dataset are as follows. Then in order to split data into training and testing sets, I have used stats function, splitting the data into the respective four variables. Then in order to train regression model, I have used linear regression method. In order to make predictions, I have used predict method. And in order to evaluate the model, I have used various steps. For example, mean squared error, root mean squared error, R squared. Then in order to visualize the actual parameter versus predicted parameters, I have imported matplotlib library with alias name as PLD. And in order to explain or display actual prices, we used X label. Predicted prices, we use Y label. And in order to show title, we use title function with the title actual versus predicted prices. At last, we use show function to show a model. And next, I have provided the code to demonstrate stepwise regression using Python. First, import NumPy package with np as alias name, pandas package with the pd as alias name. Then we will import required necessary libraries like load boson, train test split, sm, add constant, etc. Then we will read the data with the help of load boson and store the data in boson. Then in order to convert into panda data frame, we will use the format pt.data frame and so the result in data variable. Then in order to split data into training testing sets, I have used the drop function and a test split function. Then in order to add constant to a model, I have used add constant function. Then in order to perform stepwise regression task starts here with the four common approaches: forward selection, backward elimination. First, I will create a list with that includes initial features and storing the result in included. Then I will use the while loop. First, I will store the result as false in the change variable. Then we will check the condition, and if the condition becomes true, the changed variable changes to true boolean variable. And the same process happens in backward elimination. And if all the condition fails, then break statement is used and b comes out of the loop. Then in order to perform stepwise regression to select best features, I have used stepwise selection method and so the result in stepwise selected features. And in order to show selected features, I have shown the message selected features and showing the result. And in order to final build the final model using selected features, I have used os mod function to summarize the model. I have given the message model summarization, and by using final model dot summary, I am performing the task. At last, I will evaluate the model on the task set by using selected features and test selected constant, and so in the result test selected constant and print. At last, I will evaluate the model by using matrices like mean squared error, R2 score, mean squared error, NP SQRT, and R2 score. So this was all about regression modeling. So thank you for listening me patiently.